Okay, so on this problem, I've got a wood beam. It's just a rectangular cross section, has that height to width ratio of 1.5. I know that the bending stress is allowable of 960 psi and a shear stress of 75 psi. And basically, I've got a loading here, and I want to basically figure out what B needs to be, knowing that ratio. Okay, now due to symmetry, I know a few things. I know that my max shears are going to occur over at the end point, okay, and they're going to be 15 because it's 1/2 6 times 5 on each side, right? And due to symmetry, they're both going to be that 15. Again, the area of that triangle, 1/2 6 times 5 is 15. I've got two of them, so I've got one on each side. And I also know that M max is going to occur right at the center here. Okay, so I can make that cut there, find that M max. And again, this is just due to symmetry. The biggest bending moment is going to occur at the center. Okay, so if I sum the moments again about that cut point, I'm not going to redraw it here, but I'll have M max, okay, minus 6 times 15, okay, and then plus, and then I've got, it's going to be 1/3 of the distance, so that's going to be 2, and then the area is 1/2 6 times 5, that equals 0. So I find that M max then equals 60, and this is kip feet. I want to keep that in mind as I go through. I typically want to move those to pound inches, and we will do that. Okay, so now the geometry here is simple enough that I can do this directly. I don't need a table or anything to do this. So I'm just going to say, okay, sigma is MC over I, where sigma is 960 psi. M is 60,000 pounds times feet. So I'll take that times 12 to get it into inches. C is going to be half of that 1.25b, right? The furthest distance away is going to be from the neutral axis up to the top, so that's going to be 0.625b. And then the moment of inertia of a rectangle is just 1/12 bh cubed. So 1/12 b times 1.25 b cubed. So from all of that, I can solve this thing and say, okay, for this thing not to fail in bending, my B needs to be 14.2 inches. Okay, but I need to check for shear stress as well. And for shear stress of a rectangle, we can approximate it very easily as 1.5. Rather than doing the VQ over IT, we can approximate it as 1.5 V divided by A, where V, again, is 15,000 pounds, and A is just, that would be 1.25 B squared, right? Because it's B times 1.25 B. From that, I calculate that B needs to be, for this thing not to fail in shear, needs to be 15.5 inches. Therefore, that's the answer, right? Because if it was only 14.2 inches, it would fail in shear. Shear is the limiting factor here, so I need it to be 15.5. It will hold then in bending, because bending would have been less than that, so we should be good to go with this. And again, with a rectangle cross-section, you can just do the equations directly. You don't need a table in order to do it.